In mathematics, we like to write things in a certain way for our final answer. So we want to do something called rationalizing the denominator to make sure that we do not have any irrational values like roots in our denominator. And so because these are irrational, we need to do a process called rationalizing the denominator to make it not that way anymore, to make it rational. So no more roots in the denominator. The way that we do that is we have to think about what can we multiply root 3 by to make it just a regular 3. And that answer is itself. So we're going to multiply this denominator, root 3, by root 3. Whatever we do to the denominator, we must also do to the numerator because those are like the rules of fractions. And when we multiply straight across, 1 times root 3 is just root 3. So that's what we'll have there. And then root 3 times root 3 is root 9, but root 9 is just plain old 3. That's kind of nice. Now, can we simplify anything? No, we can't. This is root 3. It's not just a plain old 3. We can't cancel these at all. So this is actually our final answer. Yes, it looks kind of still messy, but we have rationalized the denominator, and that's what counts. All right, it's the same process here. Now you will look and see root 8 can be broken down. There are a couple different ways that this is taught. Sometimes people will simplify the radical first, which was the previous video, but I don't see the point in that really. I like to just simplify it at the end. So the way I'm going to teach it is just the same process. We're going to multiply both the denominator and the numerator by root 8. So we'll be left with 6 root 8 in the numerator. And again, a root times itself is just that number, 8. Root 8 times root 8 is root 64, and root 64 is 8. All right, now we have some simplifying to do. The first thing that I recommend doing is breaking down the root. So yes, 6 over 8 can simplify. You can totally do that first if you want, but we'll have to simplify again at the end anyway. So let's first break down the square root of 8. And if you do not know how to do this, I'd recommend watching the Simplifying Radicals video. All right, the square root of 8 can be written as 2 root 2 because it becomes root 4 times root 2, and the root 4 becomes a 2. All right, so now what we have is we have 12 over 8, if you want to look at it like that, or kind of an interesting mathematical thing you can do is just simplify the 6 over the 8. They're both divisible by 2. So this becomes a 3 and this becomes a 4. Then we can simplify the 2 over the 4. That becomes a 1 and this becomes a 2. Kind of an interesting way to do it. All right, then we have 3 times 1, which is 3 root 2, all over 2. And again, you can't simplify this 2 and this 2 because this is not really a 2, it's a root 2. So our answer is done. This last problem looks the most complex, but it's really similar to what we just did. Yes, there's a 7 in the denominator as well, but we're just going to ignore the 7 because it doesn't really matter. So we're going to multiply the denominator by root 24, and we'll multiply the numerator by root 24. All right, so in our numerator we'll have 8 root 24, and in our denominator we'll have 7 times root 24 times root 24 is plain old 24 from the pattern we've seen. All right, now from here, I'm going to break down the square root of 24 in this next step. So we're still left with an 8. We're still left with a 7 times a 24 down here. The square root of 24 can be rewritten as root 4 times root 6, and the root 4 becomes a 2. So this is written as 2 root 6. And now, instead of multiplying out 7 times 24 and 8 times 2, we can just cancel what we can. So I'm going to look at this 8 and this 24, since they're both divisible by 8. 8 fits into itself once, 8 fits into 24 3 times. Now I want to see if there's anything else that can cancel. The 1's kind of done, but 2 and 7 can't cancel, and 2 and 3 can't cancel. So our final answer becomes that 1 times 2 with the root 6 in the numerator, and in the denominator 7 times 3. So there we have our final rationalized answer.